Good afternoon, everyone. Please kindly be seated, everyone, because we have to start the session shortly. Welcome you all to the post-noon technical session of Day 2 of Commonwealth Forestry Conference 2017. The theme of the session is Impact of Climate Change. Undoubtedly, climate change has emerged out as a major global threat and need to be addressed with utmost priority. There is an urgent need for a better understanding of the interaction between forest, water, and climate change, and I hope that the recommendations of the session will cater it. We have amongst us the moderators of the session, Dr. Rajan Kotru, EC Mode, Nepal. Welcome you, sir. He is a development specialist with over 25 years of experience in research and development cooperation projects, mainly in forest ecosystem dynamics and sustainable natural resource and watershed management. And our second moderator of the session is Dr. Jagdish Kishwan, former Director General ICFRE and IFS. Dr. Kishwan has an experience of more than 35 years in administrative and research assignments dealing with the issues of management, policy, research, education, and training related to forest conservation, wildlife, and climate change. Welcome you all, sir. Now, we have amongst us three presenters, Dr. Rinku Moni Devi from India, Dr. K. Jaisurya from India, and Dr. Ankur Avadia from India. I would request, there are two presenters, S. Khajuria from India and Mike G. Cruikshank from Canada. If they are among the audience, kindly have seat on the dais. Okay, now I would hand over the stage to our moderators and request them to kindly conduct the session. Please, sir.
Thank you very much. Good afternoon, ladies and gentlemen, distinguished audience, and also good afternoon to my chief moderator and presenters. Well, we have a very important subject, and we know that climate change, when it comes to forests, it immediately evokes threat, it immediately evokes challenge, and of course the complexity with which we have to deal the very famous ecosystem, the forest ecosystem. I think that's one part of it, but second part of it is that on one hand, the forests, they influence the climate, microclimate, but the things have now turned other way around. The current climatic changes are actually influencing our forests. That's definitely true, but we don't know what is that dimension. What are the short-term changes? What are the long-term changes, especially in South Asia, where limited research has been really put into practice so far. So therefore, this session is very important, getting the first insights into the research related to climate change and their impact on forest ecosystems. Having said that, we also know that apart from climate change, which might be variability of temperature, precipitation, humidity, we know that there will be also extreme events. And at this point of the time, we don't know how these extreme events, such as drought, pests, will definitely influence our forest ecosystems. So let's keep ourselves ready for some very good presentations, and then I do expect very vibrant discussion because forests are changing in terms of their functions, in terms of their structure, and in terms of also the overlapping impact of direct human impact and the indirect impact of climate change. So, ladies and gentlemen, we have 5 key presenters, and as was said, we have 3 already who are here. May I invite the very first one? Yeah, please. I hand over to Dr. Jagdish.
Thank you very much, Rajan, for giving that good start. Let me say a few words now before I call on the first presenter, Ms. Rinku. The impacts of climate change are very well known. It's not only forest that the climate change will impact. It's the health, food, water, development also, the livelihoods, and of course the environment. But here we are confining ourselves to the impacts of climate change insofar as the forest and associated biodiversity is concerned. Now, in fact, when we say about forest, impact of climate change on forest, forests in fact have to adapt themselves. So it's a double-edged sword for forest. They have to adapt themselves, and in fact, they help in adapting the local communities also by giving them food supplement, by giving them shelter against storms, by acting as windbreaks, and also in helping soil and water conservation, thereby ensuring the water and food security. And in fact, you really cannot separate mitigation from forest. They act as carbon sink, all of us know, and in fact, we are going to have a presentation on that also. So both adaptation and mitigation, these are to be planned insofar as forestry sector is concerned. And our NDC, which we have been discussing since morning also, it clearly lays down the pathway for the forest. When it says that 2.5 billion tons to 3 billion tons of additional carbon stocks will be sequestered by 2030. Of course, everybody is saying how it can be done, but maybe it's possible. And now we come to the presenters, and let me lay down the rules also. Yeah, every presenter will get 10 minutes. After 8 minutes, we'll give you a signal, and please wind up in next 2 minutes. So with that, we can always call the first presenter, Ms. Rinku Moni. 8 plus 2 minutes for you. Right?
A very good afternoon to all the panel members, faculties, colleagues, and my dear friends. Today I am going to present on the topic application of regional climate models in assessing climate change impact on forest of Kanha Tiger Reserve. It is in Madhya Pradesh. So my plan of presentation is background, objective, methodology, study area, data sources, result, conclusion, and references. Background, we all know that climate change, it is a global concern and it is impacting physical and biological systems. And it has influenced the distribution, structure, and ecology of the forest. Developing countries are impacted more as there are less technological and financial problems. And in recently, Sustainable Development Goals, climate action is incorporated. Climate change in forest. Climate is the key factor in determining nature composition and vegetation patterns globally, and it influences the distribution, species composition, phenological activities, productivity, structure, and ecology of the forest. And it is also influencing the physical and the chemical biological processes that is in the earth atmosphere. As per IPCC, we all know that worldwide 20% GHG emission is from deforestation and degradation, and our forest, it helps in potential slowing down the current trend of global warming by sequestration. And impact of climate change on forest ecosystem, we all know that there may be extinction of species, biotic stress, hydrological issues may be there, and biodiversity change may be there, and there may be attack of pest and forest fires. I am considering a model. It is called regional climate model, and model is a technique for climate simulation that we go for projections, future projections, and we can also predict the past, and we can simulate it and predict for the future. And it uses the differential equations like conservation laws formulated based on factors governing the physical behavior of the atmosphere, and it divides the Earth into 3D grid coordinate system, and implements in 4D data model where there are dimensions like latitude, longitude, vertical level and time, and it is in gridded form, and data is stored in series of points spaced at regular intervals. There are models like GCM and RCM. GCM is Global Circulation Model and Regional Climate Model. GCM used for simulation of global climatic system, and RCM used for regional climatic system. GCM has coarse resolution and RCM it having fine resolution. Grid spacing is 100 to 200 in GCM and 20 to 60 kilometer grid spacing in regional climate model. So we go for regional climate model for fine resolution and better estimation for future. There are various studies which uses climate model, like for policy formulation and adaptation. INCA has used 50 into 50 kilometer resolution. Then climate change impact on forest ecosystem. HEDRIM was used by Ravindranath, 2005, shift in vegetation, 48.44 kilometers. These are the studies where in different sectors the climate models has used, but we are going for a model that gives fine resolution, like we can go for 0.25 resolution. These are the studies where the resolution was 50 kilometers, but for our future betterment of climate change or mitigating the climate change, we should go for some models that uses a lower resolution. In my study, it is seen that from various literature, there are limited studies in India lacking accurate and high resolution prediction, application of modern tools and techniques. Integrated research should be there, and to understand the potential application as well as limitations of the climate models and remote sensing. We can go for the three, like forestry, climate and remote sensing. We can go for integrated approach for better policy and adaptation strategies. My objectives are to understand the variability in the past climate and intercomparison between different sources of data, and to assess the change in vegetation of Kanha Tiger Reserve. Methodology, I am using climate data, that is precipitation data, and resolution of IMD data at 0.5 and IMD 2, that is 0.25, and REMO model, that is climate model, I am using at 0.5. And we will, I am comparing it in annual rainfall, seasonal and number of rainy days. Correlation analysis was done. And for objective 2 change detection by remote sensing, change in core and buffer area in time period 1990 to 2016. Satellite imageries, Landsat 5 and Landsat 8 were used. Then FCC formation, area of interest formation, and NDVI and image difference were calculated. This is my study area having core and buffer zone with coordinates 22.33 degree north and 80.63 east, having area 940 kilometers square, buffer range have 6 range, core have 6 range, and Sal is the dominant forest with mixed forests were also there, and Terminalia genus is other common spaces. Details of the data set where I am using IMD1 from 1971 to 2005, IMD2 1971 to 2015, then model it's from 1971 to 2015, and local weather station data were there. This is a representation of my gridded points. Results showing that annual precipitation IMD at 0.5 into 5 shows there is increasing in rainfall and then decreasing, and in REMO it is abruptly decreasing. In IMD 2.5 degree, it is shown that there is abruptly decrease in annual precipitation. Like 2014, you can see there is decrease in rainfall. Total number of rainfall days, it is decreasing. And seasonal variability, I am using clubbing the months like March, April, May, MAM, JJES, that is June, July, August, September, ON that is October, November, and DJF that is December, January, February. The monsoon months, it is shown in the graph. Some are decreasing, some are increasing. You can see that. This is the precipitation of the model, which shows that there is decrease in annual precipitation, and temperature also shows decrease in precipitation. A local weather station, in the ranges, I have analyzed the monthly precipitation trends, which showing that abruptly decrease in rainfall, abruptly decrease in temperature. Seasonal precipitation at Sukfar range, that is also decreasing. Then NDVI index, it is shown that there is decrease in NDVI.
Ms. Rinku,
yes.
2 minutes are left, and
Okay,
you can
sir.
come to the impacts now which you have seen by using this model.
Okay, sir. NDVI is also decreasing. From imagery, from NDVI calculation, it is shown that there is decrease in forest. The red parts, there is dense forest, and it is decreasing. Core area. And from change in vegetation cover, it is shown that in poor vegetation, there is decrease in area. In low, there is increase, and moderate, there is increase, and in dense, there is decrease in forest cover. Here again in core area, you see that poor, there is decrease, low decreasing, moderate decreasing, dense, it is increasing. This is change detection in buffer, areas where within 10% and within 30% threshold, it is seen that there is decrease in forest cover. Change in buffer, it is a core zone where change is 10% and 30% decrease in forest cover. And my conclusion is that among all the 3 graded points, IMD 0.2.5 and 0.2.5 and IMD 0.5, there is positive correlation with sample 34 and correlation that is 0.56 with significance 0.01. Abrupt change in precipitation is seen. Then there is a change in increase or decrease in forest cover, it is seen. Integrated approach involving application of different suitable climate models like climate models, remote sensing and field survey could generate accurate information at a scale that is lower, that will be fine resolution which can help in planning adaptation strategies like in forestry sector and also for control levels. References are this, thank you. And any questions, you're welcome.
Questions we can have at the end.
Okay.
Yeah? Let the next presenter go.
Thank you very much, Dr. Keshwan. Now we have the second presentation, Deforestation-Led Climate Change, Its Effects on Women, Indigenous Forest Dependent Communities by K. Jayasuriya. Looking forward to that because women will be hard hit by, as we have seen in different studies, that they will be one of the target groups which will be hard hit by climate change, and therefore very much looking forward to your presentation. Please go ahead.
Good afternoon to one and all. I'll be speaking about deforestation-led climate change and its impact on women of indigenous forest-dependent communities. My presentation is based mostly on secondary data and focuses on very few examples, but the contents of the presentation include interconnection between forests and climate change. The second part of the presentation is about the effect of climate change on women of forest-dependent communities with examples of Sundarbans and forests of northwestern India. And the final part is about the shortcomings in addressing these issues and possible solutions. First, I will begin with explaining the role of forests in climate regulation and how deforestation contributes to climate change. So as we all know, forests act as major carbon sinks, and by absorbing and storing the carbon in solid form, they help in keeping a check on the global warming and control other phenomena like ocean acidification that come with the excess of carbon in the atmosphere. Secondly, they maintain the water cycle and regulate the amount of water vapor in the atmosphere. The two ways in which forests affect the water cycle are by their effect on the amount and dynamics of the stream flow and groundwater, and secondly, the influence on the water quality. And in case of, say, rainfall, soil property is something that is very important, and forests control the hydraulic capacity and capacity for soil water storage, and the way in which the pathway that the water takes is important in determining the hydrological response. Secondly, the cloud water deposition. The presence of forest canopy as an obstacle causes water particles to coalesce and be deposited as precipitation. And so even if it's not the cloud forests that are getting depleted, even in case of forests which are well below the cloud base, it can alter the extent of convective boundary layer and raises the cloud base and thereby increases the altitude at which the cloud deposition occurs. Then there's also the effect on soil, which is also a major carbon storehouse. Forests can influence the runoff of soil in case of heavy rains, or the removal of the protective layer of the canopy cover increases the detachment of soil particles by the raindrops, and areas compacted by activities like logging and road construction are more susceptible to erosion. Now we'll come to the impacts on the forest-dependent communities. In extreme weather conditions, heat stress, drought, and flooding, increased risk of forest fires, increased risk of pests and disease outbreaks are among the major threats to the forest-dependent communities. There's also an increase in the safety net role of forests, which is among the ecosystem services that the forests provide to the dependent communities. And so in case of crop failures, which often come as a result of the repercussions of climate change, more and more communities depend on the forest and its ecosystem services. And hence, there are those communities which are rendered helpless in case of climate change affecting forests. Now we'll come to the effect of climate change on women. I'm going to talk a little about the Sundarban forests of Bangladesh and India. In India, in India and Bangladesh, what has been observed is that there has been a considerable variability in temperature and rainfall in the Sundarban forests, with maximum temperatures increasing and rainfalls becoming heavier. On a study that extrapolates the data on frequency distribution of cyclones in the Bay of Bengal, it has been seen that the number of cyclones is predicted to increase manifold, and it has been seen that there will be a 3 to 5% increase in wind speed per degree Celsius rise in sea surface temperatures. So this will affect the Sundarban forest adversely. And the communities dependent on it will be, the livelihood sources will be affected. So first of all, major livelihood options of the communities living in these forests is agriculture and aquaculture along with fishing. Due to rise in sea level, which is also a repercussion of climate change, we see that the agricultural lands and aquacultural ponds are inundated with salt water, and this increase in salinity affects affects timber production, non-timber forest production, and other activities like fishing and aquaculture. So what happens is, especially women resort to activities like prawn seed collection as a result of this. And even after major cyclones take place, this is what most communities resort to. And what happens as a result is that many women on a day-to-day basis undergo many adverse effects, like several women succumb to death Some of their hands and legs get cut off due to encounters with crocodile and shark bites, or they sustain injuries like fractures. Some get skin diseases due to spending long hours in water with increased salinity. This affects their marital life. Some even face separation. There are men who are involved in catching crabs. These, when often they cross the safety limits and get attacked by the Royal Bengal tigers, and the wives of these men get widowed. Then there is those others who migrate to towns and cities for a livelihood, in turn putting pressure on the women of these families to sustain the villages and provide for their families. Now coming to some forests in the northwestern regions of India, it is the women of the poor, peasant and tribal households who do much of the gathering and fetching from the forests, village commons and rivers. So women have a significant responsibility, and mostly they're the sole economic providers to these households. So what happens is, in cases of water shortage and other impacts that these forests undergo, it is the working day of these women, which is already 10 to 12 hours long, that lengthens with the depletion and reduced access to forests, water and land. And women and girls are often the first ones to reduce how much they eat and sacrifice their diets for other family members. So this also affects their nutrition. Finally, I'll come to some shortcomings in addressing these issues. While practices like assisted migration may help in protecting some species of plants and forests affected by climate change, there are major voids in policies to address the needs for the communities dependent on these climate change affected forests. Some existing state policies are silent on the gender aspect of many of the problems faced by forest dwellers on other forest-dependent communities. This is especially the case in India, where gender-neutral policies not only fail to address the complexity of the problems, but also sometimes worsen and perpetuate these problems. And increasing difficulty in meeting these basic needs like food, water, and nutrition deepens the misery of these forest-dependent communities in terms of deepening poverty and deteriorating public health, hygiene, and increases social conflict. Finally, some solutions to offer to this could be to provide alternative coping mechanisms for vulnerable communities that would otherwise use forests as when facing crop and livestock failures.
Ms. Jasure, 2 minutes.
Yes. And there is an urgent need to improve welfare through sound governance, strengthening institutions, greater participation and education, greater accountability, reinforce monitoring, and community access to benefits. I feel it is very important to involve the local communities in these policy making, as every location has a different need, and the vulnerabilities vary from region to region, and so a blanket policy, in my opinion, is not effective. There should be a promotion of charcoal or other efficient renewable fuels to gradually replace firewood. This is again in focus to women who are mostly involved in gathering firewood. And finally, there is a considerable gender gap in access to decision-making authority at all levels, local and national, including decisions about resource use and management. And I feel like this gap should be bridged in order to deal with the problems that we currently face. Thank you.
Thank you very much, Ms. Rinku. And now we can call on the third presenter, Mike G. Cruikshank, and he's going to tell us something about the wood properties of, you did say this half sibling of Douglas fir, how the properties, these get affected by root disease, is it? Root disease? And then the commercial value also goes down? That's
Yep.
what, yeah, okay. Yep. Please go ahead with your presentation. 10 minutes for you.
Okay, thank you. So just going to talk a little bit about environmental impact and product end use. We talked a little bit about products here, but not very much. So I'm talking about Douglas fir, and the two impacts are, well, climate and pests. And the climate and the pests interact, and we can't predict those very well. So the impacts are going to be on growth, survival, and product value. And so we need to figure all these things out when we're looking for trees that we want. Which trees are the best? How do we find them? And we need to look at more than one trait, because they have to survive a whole suite of things in the environment, not just one thing. Okay, and because I'm a plant pathologist, so I'm gonna talk a little bit about resistance, tolerance, and susceptibility. And how does it relate to wood products? So I just got to review a little bit here on what's resistance. So when you put plants under stress, they respond in two ways. They adapt or die. The susceptible trees are dead trees. And resistant trees, they survive, but they limit the stress agent in some way. So it limits plant damage. A tolerant tree also survives, but it copes with the stress agent. So basically it limits the effects of damage. So it grows better for a given level of damage. And so you can see on the bottom there, I just gave that little diagram there. Either it dies, survives. If it survives, it limits damage, it's resistance, and you get small lesions, and you get it costs though to do that. And then when you have tolerance, you get probably larger lesions a lot of times, and you have a lower growth impact than usually resistance. So the host defense, we have two basic defense mechanisms. Constitutive, they're pre-existing, they cost all the time, or there's induced that cost after it's induced. So we tend to think of things in terms of biochemistry and what they cost to synthesize things, but we don't look very often at other effects like physiology. So we're missing something here, and that's what I'm going to talk about today. And the reason is if we select for one trait, we miss another one, well, that's no good. So what exactly is tree resistance, and what are we looking at in this system here? So here's the methods. These are half-sibling trees that I got from the Ministry of Forests in British Columbia, and they're 5 families, and they're susceptible, resistant, and tolerant. And what I did is I infected them with Armillaria stoyae, which is a root disease, and you can see the blocks there at the bottom of the tree. There's 2 big blocks, 1.5 kilogram blocks with the fungus in. You bury them, wait 5 years, it comes out and infects the tree, and then we take cores out of the tree, and we sample the lesions, and then we scan the cores in a SilvaScan. It's an optical fiber scanner. It gives us wood properties. These are the lesions here. You can see the top right is susceptible. You see the lesions spread horizontally. Well, it doesn't take very many of those to girdle that tree, and then it's dead. Whereas the tolerant trees, they survive, but they have those vertical shaped lesions. Same area, same lesion area, but the lesions are vertical, so they don't girdle the tree, so it survives. The resistant trees are down the bottom right. You can see they're very small lesions in all directions. Well, that costs a lot, whereas tolerance doesn't cost a lot to the tree in terms of growth. So the biggest impact, or the biggest overall study result was we have found higher wood density in resistant trees. And basically you get higher density by thicker tracheid walls, lower tracheid radial diameter, and increased proportion of late wood. And you can see on the right-hand side, there's the late wood. You can see it's got low radial diameter, very thick cell walls. It's pretty dense wood versus the early wood where their cells are very big. They have a very large radial diameter, even longer than their width. And so the early wood's configured for growth and the late wood for cavitation, protection. And so when you look at lumber, when we cut lumber out of there, we need high density and strength, pretty much. And it relates to warp, twist, and bow. I'm going to talk about that later. So here's the data. You can see y-axis is density, and then the year at the bottom, those are just the annual rings. So we're just looking at the density in the annual rings. And the top series of lines, those are the 75 trees that make up the 5 families. And the solid small lines are the healthy trees, and the dotted lines are the infected trees. And then that vertical red line, on the left-hand side of that line, all the trees are healthy, and on the right-hand side, it infected half of each family, okay? And then the big solid line is the average of the healthy, and the big dotted line is the average of the infected. So you can see on average, there's an increase in density. And then on the bottom, I'm just going to show you the one line, mean summer precipitation. It's that line that jogs up and down. You can see it tracks fairly well with wood density. So when we have more summer precipitation, we have more density. So if we're going to have less rainfall in the summer, we're going to have lower density wood. So this is the same data, but it's separated by family now, by half-sibling family. There's the 5 families. You can see them labels on the right. Again, on the right side of that vertical line, you can see how the wood density jumps up dramatically all of a sudden after the trees are inoculated. And you can see there's an up and down jog through the healthy trees as well. That's the climate signal. And you can see it carries over into the infected trees as well. The disease just adds to it. But that initial jump there is the disease effect. And it's much bigger than the climate signal. And you can see on the top, the dotted lines on the top, I just put in red there, I put R and T. Well, those are the two resistant. You can see they're at the very top, tolerance next down, tolerance susceptible is the lower category. This is the early wood tracheate radial diameter on the y-axis. And you can see all the trees, there's no statistical difference between them when they're healthy. So you can see that solid line tracks all the way through right to the end. But when you infect them, you can see there's a big separation in what they do for disease. And then also the up and down portion of the healthy, that's the climate signal again on radial diameter. And you can see the resistant trees, they're labeled they're big R's, red R's. You can see they're right at the bottom. So the tracheates actually have less radial diameter, quite a bit actually. And because of that, you lose radial growth in the tree. So here's what the wood looks like. So you can see this is probably a little bit easier to understand. You can see the wood starts off concentric rings. They're fairly large, lots of early wood. Because this is a really good growth ecosystem, by the way. There's lots of moisture around. But you can see where that arrow points, that's where the infection starts. And you can see what happens. There's a huge reduction in ring growth, thicker cell walls, less radial growth. And you can see on the opposite side, down on the lower left, you can see it does the opposite. It's trying to compensate for the loss of a root. And then that compression in the rings there, that's directly over an infected root. So it happens in these columns over the roots, which is not good, because when you cut lumber out of there, now you have different density in the wood. And I'll show you what happens in a minute. So just to give you a little background here on tracheids, these are gymnosperms, they have tracheids. When the radial growth shrinks, the tracheid's smaller, and you have less bordered pits, and the water flows through the border pits, up the trachea, and out the next border pit into the next trachea. That's how it goes up the tree. So when you have more late wood-like, you have less bordered pits, so there's a lower probability of failure. You also have thicker cell walls, and the pits tend not to pull
2
up.
minutes for you.
Okay. So the resistant trees have better cavitation protection. And then I cut some lumber out of trees as well. The black bars are healthy, the red bars are infected. There's 3 trees each, and they're paired by the same diameter. You can see you get more wood out of the healthy trees, even though they're the same diameter, because the disease changes the taper. That's why. And then the downgrades are knots for the healthy trees, but it's warp for the infected trees. And warp's a very serious downgrade. You can see there's a 2x4. That's a dimensional lumber in North America. You see that ring pattern? I don't know if you can see that on the screen there, but it's the same as that wood disc I showed you. It's very dense on one side and very undense on the other, and you can see the bow and the wood. Well, that lumber goes from top grade right to the bottom, and that's what resistant trees do. Tolerant trees don't tend to do that. So this is the last slide here. So basically, just to sum up, we get disease causes a large and sudden sustained fluctuation in fibers. Most of it is density, but there's other ones I didn't mention. Climate tends to cause this up and down cycle where it's not so bad on wood quality because it's up and down. It's not just this sudden and sustained change. Resistance, it costs in volume and value, but it's benefited. Trees really survive well, but not better than tolerant trees. Wood density is the most effective fiber. We got thicker tracheids. We have reduced failure by cavitation. So it's just kind of a loss. It's just a reaction, a physiological reaction to loss of root function. That's what I think. And it's not just a cost of defense. I used to think it was a cost of defense. It is in a way, but it's not a biochemical cost. So if you look in the literature, drought tolerant there's lots and lots of literature about wood density being correlated to drought tolerance. So, resistant trees, they may be more drought risk adverse. They may not like to have that. But we need to explore that. And I just wrote a paper in Forest Ecology and Management. So if you want to look more on this, I couldn't put a lot of background into this. So that's it. Thank you.
Thank you very much, Mike. Quite an interesting subject, what to do with the wood, especially looking for resistant traits and then working on them for bracing up climate change adaptation when it comes to managing wood. Well, we have the next presentation, again about a species which is enigmatic species, Pinus roxburghi. Foresters love it because it is definitely one of those species which can survive grazing, forest fire, and even degradation. Yes, that is one part of it, but the second part of it is also there may be the counter evidence which might say they dry up our water sources as per the people. And no, a lot of conflictory, I would say, evidences against Pinus roxburghi. Therefore, we are looking forward for the presentation by Mr. Ankur Avidya to talk about Pinus roxburghi. 10 minutes. At the minute number 8, we will sound the first bell.
Thank you, sir. Good afternoon and namaste. Afforestation has been the kingpin of our endeavors to mitigate climate change. We know that through the process of photosynthesis, trees convert sunlight into bioenergy, sequestering carbon dioxide in the same process into biomass. Carbon dioxide being a key factor driving global warming and climate change, sequestration of this compound naturally helps mitigate climate change. But it is after we have resolved to plant these trees that the convolutions of options arise. The proverbial devil always lies in the details. Once we have decided that we are going to plant these trees, which species should we plant? Can we prescribe just one species or just a small cohort of a few species for a whole country or maybe for a state? Is this decision concealed in site conditions, or does it depend on the prevailing climatic conditions, or on a combination of these factors, site conditions, the species characteristics, climatic conditions, and maybe some other factors that we have not yet realized? How do we decide then? And even after we have adopted a mechanism of taking these decisions, how are we to get the raw data? Can we rely on experiments? Let us remember that tree stands have extremely long rotation periods, making experimentation results difficult to obtain. Can we wait for that long is the prime question. Or is there a mechanism of somehow simulating these various processes? Today I'll talk about some of these issues. To begin with, there are several key questions that need answering. For instance, how would global warming actually affect the stands? When we talk about afforestation to mitigate climate change, the need is for mechanisms that assert a negative feedback loop on global warming. That is to say, as global warming intensifies, we need some mechanisms that make the stands sequester more and more carbon and thereby counter global warming. If we chose such species that sequestered less and less carbon as global warming aggravated, we would have a lost battle on our hands. So we need to analyze not only whether the species could thrive at a site, but also the impacts of global warming on the forest stand dynamics of those species at those locations, even before we determine that those are the suitable species for climate change mitigation. Now, global warming can be said to have two mechanisms of impacting forest stands. Carbon dioxide, being a reactant in the process of photosynthesis, should fertilize forest stands. Thus, as the concentration of carbon dioxide in the air increases, the stands should do more photosynthesis and so sequester more carbon. But the impact of warming, on the other hand, may be beneficial or detrimental to a particular forest stand. We need to determine which of these factors dominate and how a particular forest responds to global warming. So we employed 3PG model to simulate chewed pine stands of Almora district of Uttarakhand. The next few slides are courtesy Peter Sands of CSIRO, who designed the model based on allometric equations. Essentially, this comprehensive model is a carbon balance model. It incorporates equations for assimilation and allocation of biomass, impacts of site and environment, especially temperature, fertility and vapor pressure deficit, soil-water balance, stocking and mortality. For the raw data, we performed smoothing of temperature and precipitation meteorological data. Other parameters required for the model were taken from published literature. Now, every model needs to be calibrated before use, and we calibrated our model using the yield table data as published by FRI and using values from the published literature. In these curves, the smooth line depicts the values that we obtained from the simulation model, while the crosses represent the values from the yield table and from the published literature. The values of stand volume per hectare, number of stems per hectare, basal area per hectare, and the leaf area index obtained from the simulation model closely matched those as obtained from published literature after the process of calibration. So we have pretty high confidence in the model now. Next, we studied the impact of global warming on the volume of stand per hectare. These results are divided into 3 panels. The top panel depicts the impact of changing carbon dioxide concentrations in the air when temperature is kept constant at the current conditions. Now, 360 ppm is the contemporary carbon dioxide concentration in the air. 421 ppm is the concentration of carbon dioxide that would cause a radiative forcing of 2.6 watts per square meter, referred to as RCP 2.6. RCP standing for Representative Concentration Pathway Trajectories as defined by IPCC in their 5th assessment report of 2014. 538 ppm, 670 ppm, and 936 ppm are the carbon dioxide concentrations corresponding to RCP of 4.5, 6, and 8.5. We observe from the top panel that these curves have the familiar sigmoidal shape that we are so accustomed to seeing when we plot stand volume per hectare versus the age of the stand. Secondly, we observe that when carbon dioxide concentrations increase under current temperatures, the curves shift upwards, indicating the fertilizing impact of carbon dioxide over stand volume when temperatures are kept constant. The bottom left panel depicts the impact of radiative forcing only, keeping the carbon dioxide concentration fixed at the current conditions of 360 ppm. We observe that radiative forcing, by increasing the ambient temperature, reduces the stand volume per hectare, and the curves shift downwards. Intuitively, we can explain this result by considering the fact that pines are species of low temperatures, so higher temperatures could be forcing them out of their norm of reaction. The bottom right panel depicts the joint impact of increasing temperatures and carbon dioxide concentrations. In this particular case, the carbon dioxide fertilization effect dominates. However, we also observe by looking at the y-axis scales that the magnitude of the effect has diminished considerably from 2.5 times in the case of the upper left panel to just 1.5 times in the case of the lower right panel. The simulation also suggests that till RCP 2.6 conditions, the impacts on the stand volume shall be negligible. Next, we studied the impact of global warming on the mean annual increment per hectare. The curves are placed similarly as in the previous exercise, and we observe here too that while the curves have familiar shapes, and carbon dioxide fertilization and temperature enhancements have opposing impacts on mean annual increment, the overall impact is minuscule till RCP 2.6 situations. The impact of global warming on the leaf area index also demonstrates a similar picture in terms of the opposing impacts of carbon dioxide fertilization and temperature enhancements. However, in the joint impact situation, we also observe a new phenomenon not seen previously. The curves intersect at around 100 years of stand age. Thus, in the balance of forces between carbon dioxide fertilization and temperature enhancements, age can also play a vital role. This can be explained considering the fact that younger crops are more tolerant to adverse conditions and better at exploiting favorable conditions than the older crops. A similar picture appears with gross primary productivity. Here also we observe an age-dependent response towards the opposing impacts of carbon dioxide fertilization and temperature enhancements. The efficiency of carbon sequestration as observed by the accumulation of dry matter mass per hectare also represents the opposing impacts of carbon dioxide fertilization and temperature enhancements. However, here we observe that in the older stands, the amount of accumulated dry mass reaches a peak and then it decreases afterwards, mostly since the model also accounts for mortality in the stands. This could indicate the point where the stands have become net emitters of carbon and are not net sequesters of carbon after this point, and we need to harvest the stands at or before this point for climate change mitigation purposes. The peak also shifts under changing RCP conditions, as we can see in the third graph, indicating that the age for harvest changes with the changing ambient conditions, and that is something that we need to consider when we wish to target climate change mitigation through carbon sequestration of afforestation. To sum up, carbon dioxide fertilization and temperature augmentation have opposing impacts on the studied parameters, and which of these two factors shall dominate is contingent on their nature, their relative strengths, the age of the stand, and maybe some other parameters. We conclude that since the sequestration potential of shade pine forests under this study increases with successive representative concentration pathways, they appear suitable candidates for climate change mitigation efforts, at least at this particular site, by providing a negative feedback loop towards global warming. Of course, these results, though appearing intuitively correct, are preliminary and shall need to be verified through later experiments. However,
2 minutes.
Sir, however, till we do not have hard empirical data on our hands, we believe that simulation studies could provide relevant inputs and should be considered while performing site-specific selection of species for climate change mitigation. Thank you for your kind attention.
Ankur, that was a very good presentation, wherein you linked not only the global warming, CO2 fertilization, but also the rise in temperature, and how it could be positive or negative, and then you could fix the harvesting age also of the cheat stands. Very good presentation, but certainly we'll have no more questions are coming from the floor also. Now, can we open my colleague moderator, the floor for...
Thank you very much, Dr. Keshwan. Well, quite a very diversified set of presentations, and that also shows that climate change is going to be very complex, and it will have to manage the uncertainty, as we have seen. But anything between what will happen to women, target groups, what will happen to wood, what will happen to a very remarkable tree species of the Himalayas and other places, Pinus roxburghi, and finally also the modeling approach, which one of the presentations have been really showing what will happen to forest growth, for example. So I think we open the floor with the permission of Dr. Keshwan. I would request that let's take questions in bunches, say 2 to 3 questions first, then first response, and then maybe after 2 or 3 questions have been really responded by our esteemed presenters, then we could shift to other questions. So, first, fingers, yes.
Thank you. I am NSK Harsh from FRI, Dehradun. My question is to Mike. And Mike, you have presented that pathogen, Armillaria ostoi, it is affecting the fiber properties in the trees. It is a little difficult for me to understand that how climate is going to affect a root pathogen which is buried inside the soil. And if it is, infecting the wood inside, then still it is protected from outside by the live wood, bark and all that. Then how climate is going to affect the pathogen?
Yeah, Harsh, that's a very, very good question. In fact, yes, Mike now will have to say how the climate change is going to cause this disease. He'll answer you, yes, but we can go to the next one.
I'm V.K. Dhawan from FRI. My question is that since there is ban on green felling above 1,000 meters in the Himalayas, so you said that the carbon sequestration rate is declined after a certain age in Pinus roxburghi. So at what age we should harvest this Pinus roxburghi, and so that our carbon sink or the carbon sequestration could be maintained in the trees. But if there is ban on green felling, since say about 40 years back, it was banned by the Supreme Court of India, and we are not utilizing the trees. Actually, we see that the trees which are standing in the forest are having only carbon log in them, and we are not utilizing it. So what is your perception about this?
Okay, can we have one more question and then the presenters will answer? Here.
Thank you. Should I start from the last one, or I have some other question for the first presenter? And the
Abhi
second?
ek puch lo.
One. Okay, I am going to the last presentation. There is can your model tell us how much the carbon dioxide concentration can fertilize the trees? What is your model tells us?
Okay, the questions are very clear. So should we start with the Mike? how do you connect this root rot with climate change? Is there empirical evidence for that? That's what the question was. Please, Mike.
Well, I think what you asked me is, how does climate affect the fungus itself? Is that right? Yeah, okay. Well, because it's...
Since the fungus, the pathogen, it is working in the, on the roots, which are buried inside the soil. So I presume that the soil is acting as a buffer and climate is not going to affect that fungus. Since it is moving inside the wood, wood is protected from outside, or the fungus is protected from outside by the wood, but climate is not going to affect that. This is my perception.
Yeah, well, the fungus survives a really wide range of climates, and because it's underground, it's buffered, like you say. It's only very dry and very wet, and very hot and very cold environment, so it's the tree that's mainly affected. Of course, the fungus isn't going to survive very well if there's no trees, but yes, it's the tree. The fungus does very well when the tree doesn't do well. You know, it goes back to the host pathogen climate triangle. So when you favor the fungus, the host is not going to do well. So if the climate favors the fungus, which it very well do in most of the climate scenarios I've seen, then yes, you're going to get a problem with the host, and that the fungus won't be affected very much. Does that answer it?
Yeah, okay. There could be, some doubt in your mind still, because I think that you have to have more empirical evidence to connect this root rot disease with the change of climate. And I believe that must be a separate study, and he must be, quoting from some other reference. But we can, you can come to that later on after we finish this. Yeah. Ankur, now it's your turn. There were two questions addressed to you.
So the first question had two parts. The first part was regarding the ban on green felling. Well, when we talk about a ban on green felling, we need to keep one thing in mind. Are we just policy administrators, or are we also policy makers? Because changing data can change policies. And here is where the role of scientists comes in. So if you provide hard evidence that yes, we need to harvest these species after a certain age, as we have seen in a number of presentations here, yes, the policies will change. But yeah, we do need hard data for that. The second part of the first question was regarding the rotation age. Well, I must tell you that our results here are preliminary. But what we can always say is that rotation age, for the sake of climate change mitigation, should be that age where your carbon sequestration curve goes to a peak and then starts declining. So that is for sure. Within the scope of this study, it came to be around 80 to 100 years. But yeah, we might need some more studies. But also, rotation age also depends on your purpose of rotation. So for instance, you might have a rotation of maximum volume, an economic rotation, or maybe you might even be planning rotation for biodiversity purposes, in which cases we also leave some snack trees. So it all depends on your purpose. Now, for the second question, it was regarding whether carbon dioxide can fertilize or not. Well, within the limited scope of this study, yes, we did find that carbon dioxide can fertilize, but of course, hard empirical data is still lacking, and we are working towards it. Thank you.
We can have second round of questions, and there was somebody who had number of questions, and he said that I am asking the last question first. Yes.
Okay, thank you again. Give me the opportunity. So my question for the first presenter. In her presentation, she showed that there's a vegetation cover in a Kanha National Tiger Reserve that has been increased, especially the vegetation cover from 1990 to 2016. So it shows there's a forest cover becoming dense. Am I correct? Yes. So in that case, what is the role of the climate change, or is the role of the other initiatives, management initiatives, or not? So that things I want to know from you.
Yeah, Rinku?
Actually, in core area, the dense forest got increased, but in buffer area, it was decreased. Some variations may be there. We had not studied yet. It is a protected area. Anthropogenic influences are not there. but maybe some other factors that we have to study. The study is in process, so I can say that only.
Rinku, the question was that is it because of climate change that you are having a change in forest cover, or it's because of, you did say that it's because of change in precipitation.
Yes.
So, but is that change in precipitation linked to the climate change, or it's just like that?
Actually, if there is increase in precipitation or increase in temperature, it is not sure that it will just increase the forest cover. There may be some positive effects or there may be some negative effects. So we can conclude that, sir.
No, it's okay. So the question was that is it linked to climate change, or it's just your study?
So it's
that
a
if
study,
the
not
okay.
Directly related
So
to climate change.
that answers your question.
Can I go for the next one?
Just wait. Let us see if there are others also. Yes, Rawat.
Thank you, Chairs. I am VRS Rawat from ICFRE. My question to Ankur regarding CO2 fertilization on trees. It's a universal fact that if we go on increasing carbon dioxide concentration to 550 ppm, 750 ppm, plant growth increases. But there are certain limiting factors of temperature, of water, that limits the growth of the plants. And a mature forest, there are studies that a mature forest at a certain point of time, it is a source of carbon, rather sink of carbon because of the maturity, because of age factor. So my point is, because as earlier my colleague Dr. Dhawan has also asked that even the government of Uttarakhand, they are opposing, not opposing, but they are not encouraging the cheat plantation. Why not such studies on other important species of Himalayan region that can be done, so that we can come with a policy conclusion that they are the species, they are responding positively to CO2 consumption increase, and they are the species for future. Thank you.
Yeah, please.
Thank you, sir. That is an extremely valid point, and I shall surely look into it for my next talk. Thank you.
Yes.
Thank you, Chair, and I would like to congratulate for the nice presentation, Dr. Ankul. But I have a question, whatever RCP projections that you have made, and the RCP at 8.5 is very distinct from other RCPs. What is the possible reason behind that? That is one reason that I want to ask. Your projections that you have made at different RCPs, like 6.0 and 8.5, but the RCP of 8.5 is totally, very high.
Chalo.
What is the reason behind that?
Have you got it? No, sir. See, he said no RCP of 2.6, not 3.5.
No,
Did you say 3.5?
Sir, he was talking about, in all of the graphs, he has presented RCP for 4 seasons. I mean, four RCPs. One is 3.5 and 6.0 and 8.5. So the curve of 8.5 is very, very high. So what is that reason behind it? Actually, you have modeled that. That's why I'm asking you, what can be the reason behind that?
Sorry, I still could not get your question. Could you rephrase it, please?
Okay, you need not repeat it, no. I'll tell him to, have a consultation with you after, 3:30 we are breaking. You can have a consultation, but he used only RCP 2.6, in his study. And he just made, a mention of the other RCPs, 3 more RCPs.
Sir, that is what I want to know. What is that, if you have mentioned about the other RCPs, and he said that comparatively the 8.5 RCP is very
okay,
high.
he'll take 3 more,
Yeah.
he'll take another study, and then come out with that.
Okay.
Next one. Back to.
Okay, thank you again. So I have one question for the second presenter. Especially her topic was deforestation-led climate change and its impact on women of indigenous forest. Okay? So how it is correlated with the deforestation led to climate change and some of the things she is mentioning about the salinity increase. So ultimately salinity increase and the woman activities, say for the fry collector and others. That is not clear to us.
Okay, I'll share a secret with you. I already told her that you are going to ask this question.
Okay, so in the first part of the presentation, I wish to focus mostly on the effects of deforestation on climate change in general, where I spoke about how forests affect the climate, and deforestation can fasten that process of climate change. In talking about salinity increase, what I said was in areas where in the Sundarban areas, the major livelihoods are dependent on the water surrounding the mangrove forests, which are responsible in regulating the salinity of the region. And when these forests fail to do that, and when there's inundation there due to phenomenon like cyclones, which increase due to climate change, the livelihoods of people dependent on these are getting affected, which is basically the women mostly who get affected by this increase in salinity. So that is what I tend to focus on.
And I know you are not satisfied. Are you satisfied? You are not.
I have some other
Yes,
comments.
yes, it's okay. I can understand. Because she is basically a social scientist, not a climate change scientist. And she just said that, deforestation leads to climate change locally, which may not be true, in fact. Anyone else? Yes, please. Suyal? Suyalji?
Sir, the carbon sequestration cannot be the sole criteria for, say, recommending the removal of trees. The forests and trees have lot many, say, benefits in terms of ecosystem services. So this could at best be one of those criteria, but when we actually make such kind of an argument, then we have to look at the whole, the entire gamut of benefits which arrive from the forest before we actually can, strongly argue about the removal of the tree. This is just a suggestion to you. Thank you, sir.
Ankur, please go ahead.
Okay. Sir, I must say that I could not agree more with your statement. I completely agree, which is why I said that this study was only done for those forests that we are trying to manage for carbon sequestration purposes. As I said before, we also have other sorts of rotations like rotation for maximum volume, rotation for maximum income, and in some cases, as in the case of national parks, for the sake of biodiversity, we just let mature trees rot there itself, because even a tree that is rotting is also a food for a number of organisms. So what we refer to as snack trees. So of course it will depend on why we are managing that particular stand. Thank you.
You got your answer? Okay. Yeah, now we are using a telescope, to see the people sitting at the back. And nobody is raising hands. Yeah, somebody raised the head, but not the hand. Okay, I think, Rajan, you can take over and say a few sentences.
Thank you very much. First of all, again, presenters, quite informative presentations, and also thanks to audience, which came with spate of questions, which also in a way underlines that we, when it comes to the research, both fundamental and applied research, how forest ecosystems are responding to climate change, we should be very cautious, because the research data is really on the anvil. It is not yet fully there. We know that many things have come up, and we also know that there are some areas on this planet where research has been done intensively since decades. But here in this part of the world, I think research, it shows clearly there are uncertainties in what we say about Pinus roxburghi or wood, because the data so far is very limited or has been done in a standalone way. So therefore, we should be very cautious about, we should not trust everything to the climate change. That should not be the signal which goes to those practitioners who are outside, who really like to benefit from research. And also, we should not also throw each governance problem which we have already, for example, gender sensitization, it's more of a governance issue than now climate change. So I think these things definitely I took up from 5 presentations, but I must say that the research which has been really initiated should be really built upon. And this is where the learning should be, that if, like Mr. Rawat was saying, we definitely, Pinus roxburghii is one of the prime species in the mountains, but there are hundreds of other species which are much more useful for people who are really dependent on that particular species. So I think we need to really look into that, that we are actually looking on the species. Sorry, I thought I corrected. I think, no, it's not mine. Okay. Yes. Sorry, extremely sorry for that. I think it also shows that research has to diversify. It is not only you look into the growth model of Pinus roxburghii or some other species, we have to really look into other parameters which are really linked to whatever happens to a forest ecosystem due to climate change, but also due to management which we are applying to forest ecosystems. I think both needs to go hand in hand. That will be complex because often it will be difficult to say what is human impact direct and what is climate change. So therefore, I think the research should definitely in future look into clearly distinct fields of research where we say this is only climate change related research and this is only maybe non-climatic factors which play a greater role in modifying our forest ecosystems, especially in South Asia, for instance, where human use of forests is quite heavy. So I think this should be really the starting point. And the other thing is that research can be really diversified. As I mentioned, gender has to be looked into much more strongly. The governance aspect of climate change, what will be impacted when it comes to also climate change getting quite harsh on us in the forest, people migrating, people complaining about more forest fires. I think all these issues need to be really looked deeper and associated with what are the solutions. Because ultimately people and also the ecosystem would like to get more adaptive and resilient. We have to find solutions for that. We have to find solutions for people when they complain about climate change is hitting their forests very hard or their agroforest patches very hard. I think we have to really look into that. Therefore, the solution could be, which has not come out clearly from the presentations, keeping the people in view, keeping the ecosystem in view, that we also divide our research looking into short-term solutions, intermediate solutions, and long-term solutions. And I think that's where the research on climate change should be really focusing on. Thanks. Yeah.
Thank you very much, Rajan. I'll just say a few words about each presentation. And then, of course, I was going to end with what you said, long-term, short-term research. But let me start by commenting on Ms. Rinku Moni Devi's presentation. It's a very good thing that you said that you use the regional climate model. But whenever you are using these models, these are just approximations and they really don't know what really is happening on the ground. These are very broad approximation, and you referred to the model which was used by Mr. Ravindranath also, Professor Ravindranath of Indian Institute of Science. Even that has not given a very correct picture. It only gives a very broad picture of the change in forest types of the country over a period of time. So one should be a little careful when you are using a model and you are saying that there will be change in forest cover because of the climate change. I personally would take it with a little small pinch of salt. But in any case, it's good that we should be using more accurate models for predicting the change in forest cover. I, in fact, was expecting that you will be saying that there is change in certain species. There is change in the number or migration of certain animal species or plant species which is happening because of climate change and by using this model. But this is a small replica of what Ravindranath used in 2005. we should be going down to even the species level also. And then when we go down to the species level by having the appropriate models, we can certainly plan the mitigation and adaptation measures also. So that is what I think I wanted to say about this first presentation. The second presentation was about deforestation, and it says no deforestation leading to climate change. And in fact, I did tell my presenter that one cannot say that deforestation will straight away lead to climate change. It's really a statement, no, which will be, in fact, doubted by many people, unless you are speaking of millions of hectares getting destroyed over the world. A small area, deforestation, and having the climate change at the same place, it's something which really cannot be predicted. But in any case, you can say that deforestation certainly leads to the impact, adverse impacts on the livelihoods of the forest-dependent communities. And if it is, if these are women, certainly they'll get impacted. So it's a no-regret option that deforestation should not be done. I would say that, whether it leads to climate change or not locally, deforestation should be controlled, and we should care for the livelihoods of the women folk as well as the local communities as a whole of any place. Then we come to the next presenter, and Mike. He gave a very good presentation on as to how the root rot, which he in fact correlated with climate change, and which certain participants have doubt whether this root rot in is because of climate change or it's because of other factors. That will need to be correlated based on more empirical evidence, and maybe that he has that evidence also. It's available maybe in some other paper, but it shows that this root rot disease, whether it is connected with the climate change or not, but this can lead to huge losses also commercially. And then he has suggested that you can always come out with resistant clones, which will not be impacted by this root rot disease. That's a good thing. And if there could be other control measures also, that's again, as Rajan says, a subject of research again. Ankur Avdiya's presentation was very good. I will say that very scientific. Again, I would say that it again developed a model, and he could predict as to what should be the harvest age. But Ankur, I will only advise that when you come out with these kind of models, the modeling should be followed by the validation also. Unless it is validated, it's just a presumption that it will happen like this, unless it is validated in the field. So it should be linked with the validation, and then you can finally say, yes, this model works like this. And as Mr. Rawat has said, and which has been endorsed by Mr. Kotru, and in fact, I am endorsing this, and all the participants are endorsing it, that it's not only cheed, which one should be working upon, but it should be other important species of hills and of your state, like Karkas, you have 3 or 4 species. One should be working on those species and many other species also as to how the climate change will impact the carbon sequestration in these species. And now I lastly come to this subject. Whatever we said, I would say that if you really ask me, scientifically we have not been able to relate as to whatever was happening was because of the climate change. And here I endorse what Mr. Rajan Kotru said, that to understand the impact of climate change, it's not really a short-term ad hoc research. In respect of forest and these plant species, even animal species, it's a long-term study. It's not a 1-year study, it's not a 5-year study, it's a continuous study which should be taking place regularly. Every year, observations should be there, studies should be conducted, and then based on that, those studies, the research should be undertaken, and then you should come out with references which you are able to give after having this research continuing for not only 5 years, but 10 years, and maybe even 15, 20 years also. Only then you can predict that this is what is happening because of climate change in respect of the floral as well as the faunal species of any forest ecosystem. So thank you very much. I would like all of you to give a big hand to our presenters, and as well as to the audience. It has been very participatory exercise for all of us. Thank you very much once again. Thank you.
I would like to extend my sincere thanks to our moderators for the smooth and time-bound conduction of the session and also for their valuable suggestions. And I would like to congratulate all the presenters for their precise and very informative speech. Thank you so much. And now it is a time for felicitation of our speakers. I would like to request our moderator of the session, Dr. Rajan Kotru, to please present the memento to our first speaker, Rinku Moni Devi. Thank you, sir. And I would request him again to present the memento to our second speaker, K. Jayasurya. Thank you so much, sir. Now I would like to request Dr. Jagdish Kishwan, our second moderator, to kindly present the memento to our third presenter, Mike G. Cruikshank. I would request him again to present the memento to our fourth speaker, Ankur Avadhiya. Thank you so much, sir. Now I would like to request Dr. RBS Rawat, former PCCF and HOF Uttarakhand, to kindly present the memento to our moderators, Dr. Rajan Kotru. Thank you, sir. And I would request him again to present the memento to our second moderator, Dr. Jagdish Kishwan. Thank you, sir. I would request our rapporteur team of Dr. S.K. Sharma, Dr. Mridula Negi, and Shri Manas to kindly synthesize report with our moderators of the session. And there are a few announcements to be made. First is that a side event has been organized in the Extension Hall at 5:30 p.m. on Academy of Forests and Environmental Sciences. You all are requested to kindly attend that event. And the second announcement is that there is a cultural program organized on Glimpses of India at 7 p.m. outside Pathology Division of this building only. So you are again requested to kindly attend that event also. And third announcement is that certificate of participations are ready and you can collect it from registration canopy. Thank you, everyone. And now I would request you all to kindly join us for tea, which has already been arranged in the Mango Grove. Thank you so much.